always thinking in terms of weeks. Sweet. All right. View slideshow. Control Shift C. I got to remember this one. That's easy. All right. Java class part 2 of 2. Monday was part 1, part 2. Intro. So, as a reminder, this is like an announcement. Graded assignment 1 is due. I feel like my volume went up. Maybe that's a good thing. Graded assignment 1 is due on April 13th, which is a Thursday, by 11:59 p.m. So just track that. Cool. So what to expect today? We know we're talking about classes. More specifically, we're going to talk about customizing fields. Right. So it's one thing to create a field. It's another thing to make it custom. We'll look at different options for that. We are going to talk about references, static fields, and methods. Static is a really interesting thing that we have in Java. Very different than the world of JavaScript. And then we have special methods like toString. Terminology. So I'll start this one off with a question. Someone describe the difference between a class and an instance of a class. The difference between an instance of a class and a class. No takers? Oh, sure, thank you.
So the class would be like the blueprints of a car, and the instance would be the car itself after having been built.
Great, that's a good way to put it. So class is like the blueprint for the car, and then the instance of the class is like the car itself, the object, once it's created. So yes, exactly. And one way to think about it is imagine if the class had a property called paint color. And so when we create an instance of the class, it's like the car goes down the assembly line of the factory, and then if we set the color to red, it gets painted red. And then we have a red car, which is an instance of the class, which might be like a Tesla or whatever. And then we create another Tesla, and this time we set the color to gray or silver, and it paints it silver. And so now we have two instances of the class. One's a red car, the other's a silver car. And so, keeping with the car analogy, that would be one way to think about it. Cool. So what are fields? We've been using this field terminology, but I don't know how much we've really talked about the field terminology. So we're going to break that down now. So when we were in JavaScript land, we were very used to calling an object's various data fields properties. So like an object has a property which is made of a key value pair. That's sort of how we learn to talk about objects. In Java, the terminology is expanded. So instead of calling like a class's field a property, we are actually going to call it a field. And so when we say property in Java, this is very nuanced, but when we say property in Java, we are referring to the field plus its getter and setter. So if you think about it, in JavaScript, we didn't need getters and setters. We didn't even have the option of creating getters and setters. And so a property, you could just set it and you just get the value by saying like object.property name. And so in Java, when we talk about a property, this is very nuanced, but when we're talking about a property, we're referring to the field plus the getters and the setters. And so if you're a bit thrown off by like, why are we calling the properties fields? We're just talking about the line that says like private string equals name, like that at the top of the class. That's what we're calling a field. But if you accidentally call it a property or you just prefer to call it a property, I don't really care. It's just a terminology thing. To visualize what I just described, here's a JavaScript object. This is a property which has a make, which is the key, and Toyota, which is the value. Together, that makes up the property. If we look at something similar in Java, we can see if this is what we would call a field. We're not going to call this a property. But if we combine it with the field plus the getter and the setter, now that collectively is the property. Hopefully that makes sense. I'll actually pause here for a quick question if anyone has any questions about this or follow-up questions, anything. No? Cool. Customizing fields. So we've sort of unlocked it with Java, some new ways to customize fields, and that is with things like static, final, and this is not a keyword, this is a concept, const, and then also reference. And so we'll learn about each of those today. And so up to this point, we've worked with things like access modifiers, like public or private, but there are more things we can add on to these fields to customize them further than just how we access them. So the first thing we're going to cover are static fields. Right, so here, the top part here is just a code snippet of creating a new instance of a class. We're creating an object called Bonsai, the name of one of my dogs. And so every time we create a new instance of a class, we get a unique set of the class's fields. So for example, if we create an instance of the doggo class and we give it we pass it like a string Bonsai, that instance has the name field set to Bonsai. And if we create another one called Sherlock, that instance has a name field just like the other class, but it has a different value attached to it. And so this is something we're familiar with, but I'm just kind of articulating it to set up the next part of this. So each instance of the class, they have their own unique data. This changes with the whole concept of static. So a static field is a field that is shared by every instance of the class. So if we have multiple doggo, like instances of the dog class or the doggo class, they don't have a unique, if the field is static, they all share the same field. Right, so here's a visualization of this. And this visualization is using a static field, which is the dog's ID. If we were to give them an ID number, that's what this example is trying to set up here. And so let's say the class has a static field called next ID. When we create an instance of the class for the first doggo, maybe Sherlock, inside the constructor, it says this.id equals next ID plus plus. And so next ID started at 0, it increments to 1. And so because next ID is shared by all of these instances of this class, when we create another dog, next ID does not go back down to 0, it stays at 1. And so we create another instance of dog and we say this.id equals next ID plus plus. And so now next ID is 2 and so forth. And so we are able to all the dogs are able to share this ID static attribute. And let's see if we can look at a code example of this. So conceptual, and then we have a code example. This right here is the doggo class. This right here are instances of the doggo class. We have Bonsai, Sherlock, and Totoro. And so for this doggo class, at the very top of it, we have our next ID static. Notice the static customization right here. And then we have two normal fields that we're used to working with. They are not static. They don't have static in front of them. We have name and ID. So here's the constructor. With the constructor, we take in just the name. We don't take in the ID because we're setting that programmatically. So we just take in the doggo's name. And so we set the instance field name according to whatever is passed in. So if we pass in Bonsai, name is going to be Bonsai. And then we set the ID to this incrementing next ID value. And so now we have getters and setters, well, in this case, just getters for the name and the ID. So someone could, get the name or ID, pretty standard. So in this example, this is really just an example of how static could be used. This whole concept of incrementing IDs, this is not all that we can do with static. And so, but the key thing is, what's illustrated in this slide, is that no matter how many instances of the class we make, they're all sharing this variable. They all share it. Whereas everything else, they don't share. They have their own unique copy of it. So I'm going to pause here and take questions. Here's what your questions are. Any questions or comments on static? Clarifications, anything?
That is the same field in memory, right? But they're all sharing the same memory location.
Right, yes. So next ID, yeah, it's just one location in memory. Let me jump over to the class. So this is one location in memory. And every time we create a new class or a new instance of the class, a new object, this doesn't change. It still lives in that one spot in memory. But every time we create a new instance of the class, the name and ID field, it's a new location in memory. So this is kind of meta, thinking about where things are stored in memory. But right, yes. To the best of my knowledge, I'll preface it with that, or not preface, whatever. Cool. Great question. Thank you for the question. Other questions? Yes. Hold on. Let me think about the question. Is every instance of the class an object, or is every object an instance of the class? Okay. So every instance of a class is an object. This is true. You could hypothetically create an object. I think they're both true. I'm in my own brain, I'm tripping up over the terminology, but here's how I'm thinking about it. So if we have a custom class like Doggo, every time we create an instance of the custom Doggo class, all of these are objects. Bonsai, Sherlock, etc. Hypothetically, in Java, we could create an object like a hash map that's not part of one of our custom classes. But even when we do that, even when we create a new hash map, it is an instance of the class. And so we're referencing the hash map Java class and then creating an instance of the class, our own hash map. And so that would be an object that we create. And so, yes, every object is an instance of the class, and yes, every instance of the class is an object. I'm saying that they're interchangeable for the most part, yeah. Right, so yeah, right here, yeah. So wherever we see we're creating a new instance of the class, and that instance is therefore an object. They're interchangeable in that sense, yeah. Cool. Yeah, thanks for the question. Yeah, wording is, in my opinion, maybe it's because I struggle with language in general, but wording in coding is always like the hardest things. Like figuring out how to name things like variables and classes and figuring out the terminology. I feel like that's a lot of work. And then like the whole logic of how to code things is tough, but right. Cool. Awesome. Yeah. Awesome. Thanks for the question. Other questions, other thoughts, follow-up questions, anything? Oh, yes.
So, kind of the question is, what is a class? So it's not a basic data type, and it's not an object, but you can use it like an object at times, like all these static methods, right? So like, where do classes fit into?
As far as like our class's data, is that the question?
Something like that. I guess I'm not sure where like classes fit into the structure of Java.
Right.
When you're using it, like, because you can call a static method directly, correct? Without the state being without that.
Yeah, and that does sort of break the theme a little bit, right? Because you could call a static method or reference a static variable without ever creating an instance of the class. And so in that way, it does sort of, in my mind at least, it does sort of break the pattern of like all of the data happens once you create an instance of the class, which is true for most of the fields that aren't static. Generally speaking, at least the way I think about it right now is whenever we create a static field or method in a class, that is created in memory. And so that exists almost as like those are just variables, at that point. And once but as far as like all of these other things, like these other fields that are not static, the only way that those are going to exist is if we create an instance of the class, and then that's when they exist. And so static is sort of like sort of breaks the mold a bit, if that makes sense. Hopefully my answer was not more confusing than it needed to be. Is that helpful at all? Do you have maybe a follow-up to that?
I guess I'm still confused by like when you're using a class,
Mm-hmm.
when you're using a static method on the class, what is the class then? It's not an object, right? It's not a primitive data method. So what is it?
That's a great question. I feel like I had to think about that a bit more to give an answer that's not just off the cuff, right? But that is a really good question. Like, what would you consider the class if you don't have an instance of it, but you're still able to access the static values? Yeah, it's a great question. Sorry, I don't have a great answer right now. I'll see if I can work on that one. Cool. Any other questions, including ones as hard as that one? Or something easy that I don't care. No? Okay. Cool. So we have this concept of final. Now, final basically means, the sentence up top, if we mark a field as final, we can set the value only once. We cannot change it after we set the value. So final fields are final. And so here is an example where we have a final field, which is like the dog breed. And so here you'll notice that we can set the final field when we create the doggo object. And so all of these have unique final fields. And so if we were to try to go back and change that final field, Java would give us an error. It's not going to let us change the final field once it is set. And so it is essentially the same thing as any other field, just in the fact that it's unchangeable once set. Now, a caveat to this, and this is similar to the caveat when it comes to like constant in JavaScript. So if you remember with constant in JavaScript, we could, if we set, like, let's say const aardvark equals string aardvark, we cannot change that string. But if we said const car equals object or const favorite cars equals array, we cannot change the fact that it's an array, but we can change the items inside the array. We can change the items inside of the object. And so final is very similar with that nuance where if it is a primitive type, like a string or a number, no luck, cannot change it once it's set. If it is a class type, like an object or an array list, something like that, we cannot change the fact that it's an array list or whatever kind of object, but we can change the contents of that array list or of that whatever container that we have set up to hold data. Cool. So I'm going to hold on questions here because we're going to look at something very similar, which is constant in Java, and then we'll do questions. So a constant in Java is not something that we can't just call a field in Java constant. We can't just say constant. It's not going to work. It doesn't exist. But the concept exists, and that is when we combine the two things that we just learned about, static and final. So if it is static and final, it's considered a quote-unquote constant. So here's just a graphic. Try to help visualize it. So static is represented by almond milk. Finals, a bunch of frozen berries. Throw it in a blender, we have a smoothie, and that is constant. So 2 ingredients equals 1 concept per se. So here's a code example of it. In this case, we have a constant field. It is static. It is final. It's the species field, and it's called canine. So if we're creating a new instance of doggo, we're assuming it's a canine, and we're not allowing the user to change that. And so, like static fields, all instances of the class, all these objects, they all share this exact same field, and it is final, so it means it cannot be changed. And so this is not set with a constructor. This is going to be set like this with the equal symbol, and then quote canine quote, because that's the only way to set it is when we first create it, because it's a static final field. And so if there's a lot of different ways to reference a static field. Here's an example where we're just referencing the doggo class, and we do .species, and that's going to give us canine because that's what we set it to. We could also reference an instance of the class, or if we're inside of the class, we just reference it by name. Cool. So I'll pause here for questions. Thoughts on this static final concept that we're calling constant? Any thoughts, questions? Yes.
So the fact that objects are still mutable, I get what you mean with that we can make changes there. How does that apply to strings, since strings are technically not primitives in Java, if I understand that correctly? Isn't a string considered an object?
Right. That's actually a really good call out. I'm not sure without testing it what would happen if we tried to change the contents of a string. That might be worth testing. Definitely not for a char, like an individual character. We definitely couldn't change that. But yeah, that's a good question. Could we change the contents of a string? Maybe. Yeah, we might have to test that one out. Yeah. Cool. Thanks for the question. I will throw this out there. Has anyone tried changing a string that was marked final? No? Okay. Maybe we'll mix it into whatever else we do next. Cool. Other questions on constants? No? All right, move it along. Customizing fields, we have this concept of reference. A reference field references an object. With a reference field, you can set it to reference another object. What on earth are we talking about? So let's set this up. We have Bonsai and Bonsai's best friend, Sherlock. So Bonsai is an object, technically, it's an instance of the doggo class. Sherlock is an object, an instance of the doggo class. So, I think that's supposed to say reference right there. So here, if we look at the outside of the class, we create an instance of the doggo class called Bonsai. This is Bonsai. And we create an instance of the doggo class called Sherlock. This is Sherlock. And we can set, use a setter to set who is Bonsai's best friend. Bonsai's best friend is Sherlock. And how can we pull this off? How can we say this object's best friend is this object? The way we do it is with this reference field. And so this doesn't look special. It doesn't look like there's any new syntax here. What we have is, the important part is that we have the name of the class right here. So it's the type is doggo. And then we just name it whatever we want to name it. And so when we have more than one instance of the class, we can say, okay, I'm going to set your best friend to be this other instance. Cool. So pause on the concept of reference fields. Any questions about reference fields? Okay, well, I will leave you with something to consider. Later on in the course, we are going to be dealing with databases, right? And how we will interact with those databases is we'll essentially create a Java class. And the fields in the Java class are going to correspond with the columns in the database, okay? Don't have to worry too much about that yet. This is future stuff. But let's say, especially if you've had any kind of exposure to like SQL or something like that, it's not uncommon to say like this table has an association with this table. So for an example, you might have if you were a bank, you might have a table called customers. And this is all your customer information. It's like name, etc. And then maybe you have a separate table called payment methods. And so your customer table might reference, like each name might reference multiple payment methods. And so that's just one example, but there's many reasons why you might want one thing to reference another thing. And this would be an example of how we'll do that in the future. So just thinking way ahead, nothing to worry too much about right now. So, question time. Would you make a field getter/setter static? So if you create a new field inside a class, and you're creating your getters and setters, would you make those getters and setters static? Yes, no? I saw a thumb down. Did you have a question?
Well, would it depend on if the variables themselves would be static or not?
Would it depend on if the variables themselves would be static?
The fields, yeah, sorry. But yeah, the fields. Because like if a field's static, I guess I'd imagine the getter and setter would be. And if it wasn't, then I would assume that it would not be.
Right. So that's. I feel like the answer is no. Actually, I'm going to Google this real quick. Can you set a static field? Great answer. Yes. So according to the Stack Overflow reference, we could do a static getter/setter for a static field. Right, and so this answer is expanding on it, basically saying if you were to try to set a static field with a non-static setter, it's going to complain. So great call out. Thank you. Yeah, so that makes this question a little bit wonky, but yeah. So the answer to this, the best answer to this, I would say, is typically no. You're not going to make a fields getter and setter static unless ... that field itself is static. Cool. Before we talk about special methods, any questions on that? Nope. Special methods. So this part's kind of cool. So this came up during Kahoot. The question was in Kahoot something along the lines of like, does every class have a like a toString and a toEquals method, even if we don't create it? And the answer was actually yes. All these classes, they do have a toString and a toEquals method, even if we, the developers, didn't create it. So if we were to access the toEquals method, let's look at this example right here. So this is pretty interesting, at least to me it is. We have an instance of the doggo class, and we're passing it the string bonsai. And so doggo, its value is bonsai, its name value is bonsai. We create another class the exact same way, another instance of the class, I should say, another object, and we call it doggo, we call it bonsai as well. And so you would think that these two objects would be the same. And let's even go as far in this example to assume that there is no ID field. There's only one field, which is name. And so here we have, hypothetically, here we have two instances of the doggo class with the exact same fields, the exact same values set to their fields. And then if we were to say bonsai dot equals another dog named bonsai, Java is going to say no, those do not equal each other. And so why is that? If they're the exact same objects, the exact same values, why doesn't Java think that they're the same thing? Well, we can get an idea of why Java doesn't think they're the same thing by calling bonsai.toString. So if we say bonsai.toString, it's going to give us the type of the class and then its location in memory. And so bonsai, according to Java, is doggo at 7A811970. That is what bonsai is. And if we were to do the other instance of the class, another dog named bonsai or something like that, it would probably say doggo at and then a different set of numbers. And so to Java, Java doesn't see the fields and properties, it sees its location in memory. And so if you say, is this identical dog the same as this identical dog, even though they live in different places in the computer's memory, Java's going to say, nope, I see that one lives there and that one lives over there. They're not the same. And so, in most cases, that means that the toEquals method for our custom classes isn't very useful, right? Unless we were very clear and we just want to see if they're different locations in memory. You probably don't want to do that. You probably actually want to see, are they equal? Are they the same in every other sense? Also, if we look at the output of .toString, that's also not very helpful. This doesn't tell us what the dog's name is. It doesn't tell us what the dog's ID is. It's just saying something in memory, and that's not useful to us in most cases. So the cool thing is, we have this option of overriding these methods. And so here we can say @override. So this is sort of a new bit of syntax. We have this @override on top of the method, and then we have our method. Our method is toString, the exact same name as the method that we're overriding. And here we can have it do anything we want to. We could have it do something totally nonsense, or we could have it do something a little bit more reasonable, like this return statement right here, which basically takes the name in the ID field and it prints it out. So now if we say bonsai.toString, it's not going to say its random location in memory. It's going to say it's the type doggo, its name is bonsai, and its ID is 1. That's pretty useful. I don't have an example of the toEquals. I believe there's one in the reading, and we might create one here soon. Right, so questions on overriding methods before we jump into, I guess, the exercise. Yes? So the question was, is the toString method only for the doggo class? This particular implementation of it, yes, is only for the doggo class. If we override the toString method, we're not going to override the toString method for everything. It's just going to be for the doggo class. So yeah, that's a great clarification. Thanks for bringing that up. Yeah, so we're not gonna break other things. It's just going to affect that. Cool, great question. Another question before we transition? Yes.
We're not worried about creating getters and setters for static fields. I noticed when you generate, it doesn't automatically generate them for static fields.
I would say that it's probably uncommon to do getters and setters for a static field. I would say that's probably not standard. I think earlier on in the conversation, we discovered that we could do that. There's a great question about that. We could create getters and setters for a static field, but if you notice how this one's instantiated with an initial value, that's probably how it's typically going to be handled. But there's use cases for everything, so it's definitely good to know all of the options. All right, so I'm going to try something a bit new, at least for the format, and I've got a couple different ideas on how to evolve lecture in a way that's helpful. And so we're going to, with whatever time we have, we'll get as far as we can inside the exercise to review it. So in this, we are modifying the whole grading, student grading part of the code in this example exercise. Let me see if I can increase the font, something like Control Alt something. I have to look at it again. Control Shift period. Control Alt. I'll just look it up real quick. View. Alt Shift period. Thank you. Yeah, I think I tried all the other combinations. Cool. So here's our student class. We have a static field. This is very similar to the example during lecture, and this is just used to increment the students' IDs. And then we have a more typical name field. We'll see that all the time. We have the actual ID. This one's just incrementing a number, but this is the actual ID of whatever instance of the student object we make. We have a number of credits field, and then we have a GPA field. And so let's look at the instructions. The first thing we need to do is we need to modify the student level based on the number of credits they've earned. So for example, I'm just going to copy this. This method returns a student level based on the number of credits they have earned. So this is the getGradeLevel method. I really like having the directions inside the code as much as I can do that reasonably. So this definitely looks like a switch statement or an if statement. I'm going to start with an if statement because they're easier to write, and then maybe we might consider refactoring it. So we need the number of credits. So we'll say something like if this dot number of credits, we will say is less than 30, because if it's 0 to 29, that's going to be less than 30. We will return freshman. That seems reasonable. Else if the number of credits, so we already know that it's not from 0 to 29, and so I'm just going to keep the same pattern, and I'm just going to do the less than for all of these, because the only reason why it's going to reach the else if is if this is false. And so we're going to say if it's less than 60, then we're going to return sophomore. And then we can say else if it is less than 90, we're going to say junior. And so I could do another else if, but I don't like doing that. What I would rather do is I'd say return senior. Now, can someone share why I did that? Why does this work? Why don't we have an if statement that checks this condition? Yes.
As you go through it, if the number is less than 30, it's going to return. It just works its way up. So it's already gone through the other three options. So the only thing left is
right. And why don't I have to worry about it accidentally returning both freshman and senior?
because we'll already stop the code to return freshman.
Exactly. Return is a stop sign. So everything after return, if we reach that block of code, then everything after that is just going to not run within the function, right? So that's why it's safe to just say return. We don't have to say else. To say else might be readable, but it's redundant in my opinion. So it's just a stylistic thing. I would say write it however kind of makes sense to you. Cool. So I'm assuming this works. This will get grade level. Let's see if it gives us an option to test that. It doesn't. Does anything call this? I really like testing things as I go along instead of cool. So I'm just gonna say Sally dot get grade level. I'm gonna run this. Oh, I need to print this, don't I? System out. Here we get the term freshman. So that is what we would expect because the number was 0. And so 0 is going to return freshman. And then if we change the number, if we just forced it into, say, like 30, and we run it again, we're going to get a different output. I thought. Let's see here. What assumption did I make that is not right? Ah, thank you. Thank you for calling that out. All right, so I'm going to undo that. And where we would change this, yeah, the constructor is setting the number of credits. So hypothetically, if I wanted to test it, I can just change the number of credits Sally is instantiated with, and there we get the different output, sophomore. Sweet. Cool, so assumptions have been tested. It looks like our new method works. So now I feel comfortable moving on to the next thing. I'll uncomment this. And that's something I really do recommend. As many times as you think of it, test your assumptions. Test out the code you've already written. It's a really good practice. And so we'll see if we have enough time for this. The GPA information. So we got some sort of a formula here. GPA is total quality score divided by total number of credits. The quality score is found by multiplying the letter grade by the number of credits. The total quality score is the sum of the quality scores for all classes all right, let's see here. My brain is taking a minute to catch up with the logic. Let's see, this was it get GPA, that's what this is. So I don't want that. How do I get? Okay. So we need to come up with this total quality score thing. Under add grade, let's see here. Let me double check. Ah, the add grade method, thank you. Okay. Right, because Git would just be, yeah, it would just be a getter. Okay, where's add grade? Right here. So total quality score is found by multiplying the letter grade. The letter grade is, I can probably find it without scrolling up. Let's say this dot I think it's something like possibly double. We'll have to think about that a bit more. So GPA times this dot number of credits. My brain is getting nervous and I'm getting confused here. Any suggestions on the math here? Yes.
Yeah, that's right. And then you will add the current rate to that number. And then you will divide it by the number of credits plus the number of credits that course that you include has.
Okay, so let's see here. So the
So you would take letter grade and add grade to it.
so letter grade plus grade.
And you store that in the variable.
Okay. Double. I'm just going to call this. I don't know what to call it yet, so we'll just call this something random. We'll refactor later. And the next step was
You would also add the course credits plus your current number of credits.
okay. Course credits plus current number of credits. To Kiwi or to a new variable?
That would be separate.
Okay.
It would be course credits plus this number.
Okay.
And then you would take credits divided by grade, I believe, or whatever. Your grade divided by total number of credits. Or QU divided by
Something like that. Oh, it's not returning it, so I gotta set it. So it would be this dot. We're setting the GPA equals Kiwi divided by llama, something like that. Cool, sweet. Sweet. Thanks for the assist. I think we'll call it here. But I will take one last question before we break. No questions? Great. All right, I'll see you all back at 8. Good luck on the studio, and we'll do a studio review then. Sweet.